Okay, in this video I'm going to talk about the median in a right triangle. So basically we have a triangle. So let's say that we have a triangle and we know that it is a right triangle, so this is a right angle. So then the median from this right angle, it turns out that it is equal to half of the opposite side. So like each of these half that the median divides this side is also equal to the median itself. So, and actually the opposite statement is also true. So if you have in any triangle, if you have such situation that the median is equal to half of the opposite side, then this is a right triangle. So let's write this as a theorem. So ABC, so we write that this, let it be M. So theorem, so yeah, so let's remove the right angle. Okay, so BM, so we know only that BM is a median, right? So let's write, so BM is a median in triangle ABC, and then BM is equal to 1/2 of AC, or the same as like we can write this in brackets that BM is equal to AM is equal to MC if and only if the angle ABC is equal to 90 degrees. So that's basically the statement. Okay, so let's consider the proof. So first, so first let's consider the proof in this direction. So we assume that the angle ABC is 90 degrees, so it's a right triangle, and we need to prove that the median is equal to half of the opposite side. So in this case, when we know that it's a right triangle, basically this is a median. So notice that when we consider a circumcircle around this triangle, so because it's this angle is 90 degrees, so the arc, so this is A, B, C, so we consider a circumcircle and we consider this arc AC. The arc AC is equal to twice the inscribed angle. So ABC is an inscribed angle, right? So this is equal to twice 90 degrees. So this is 180 degrees, which means that it is half a circle. So this is half a circle, right? Because the whole circle is 360 degrees. So because it's a half a circle, so let me maybe draw it more carefully, because it doesn't look like it's a half circle here. Something like this. So because it's a half circle, like it means that AC is a diameter. So it follows that AC is a diameter, and therefore the center, so the center of the circle is the middle of AC. So this is exactly the point M that we have. So because the middle of AC is the point M, so M is the center of the circle, of the circumcircle of this triangle, right? So, but if it's a center, then MB is simply equal to the radius of the circle, which is like also equal to AM and MC. So this is all three of them are radii of the circle. Yeah, and this basically proves what we need to prove. Yeah, so that's what we need. This is exactly what we proved. Okay, so now let's prove in the opposite direction. So now we know that so we assume that BM is equal to AM is equal to MC, and we need to prove that it's a right triangle. So so we have a triangle where these three segments are equal, and we need to prove that B is a right angle. So by definition of the circumcircle, then M, so from this it follows that M is the center of the circumcircle. Circumcircle of the triangle ABC, right? Because it's at equal distances from all three vertices of the triangle, and by definition that means that it's the center of the circumcircle. So then it's not just it's just since it's the center, so then AC is the diameter. AC is a diameter. Is a diameter of this circle because the center lies on this chord. So a chord that passes through a center is a diameter. So, but then if it's a diameter, then the arc AC, this arc AC is half of, well, both arcs actually, I see. This one and this one, both of these arcs are half of the circle. The arc AC is half of the circle. Is half of the circle, and half of the circle, and it means that the arc AC is 180 degrees, and then the angle ABC it's an inscribed angle, so in this circle ABC is an inscribed angle, and we know that an inscribed angle is always equal to half of the arc which it subtends. So it subtends the arc BC, so it's equal to one half of the arc AC, and so one half of the 180 degrees, and this is 90 degrees. So therefore, this is the right angle. This concludes the proof.